Hi everyone. In this video we are going to work with a couple of more complicated completing the square questions, and we are continuing to work on solving quadratic equations with our third method. Remember, when we solve a quadratic equation we are always looking for the x-intercepts of the function. So here's example 1. In example 1, I am already set up for completing the square. I've got a perfect square for a. My variables are on the left. My constant is on the right. And I don't have a greatest common factor. So the first thing I'm going to do is find b squared over 4a. Remember that b is the number that is in front of x. And a is the number in front of x squared. So 8 squared is 64, and 4 times 4 is 16. 64 divided by 16 is 4. So the number that I need to add to the left side of my equation so that I've got a perfect square trinomial is 4. So I've got 4x squared plus 8x plus 4. But whatever you do to one side of the equation, remember you have to also do to the other side of the equation. Now I've got my perfect square trinomial on the left, and I can factor. It's the square root of the first term, the sine of the middle term, and the square root of the last term. Both factors are 2x plus 2, so I write it with a squared, and that's equal to 25. We complete the square so that we can then use the square root method to solve our quadratic. So I'm going to take the square root of both sides. And once you go to take the square root, you need to split your equation up into two pieces, because remember, when we take the square root of a positive number, we actually get two solutions. The positive version and the negative version. Now I've got two two-step equations that I'm going to solve exactly the same way. So I subtract 2 from both sides, and then divide by 2. And fractions are okay. X equals 3 over 2. On the other side, I end up with negative 7 when I subtract. And again, I get a fraction, but I can just leave it. So this quadratic has two x-intercepts, one at 3 over 2 and one at negative 7 over 2. In example 2, I don't have a perfect square in front, and I don't have a greatest common factor. So I need to make a perfect square. So the first thing I'm going to do is multiply both sides of the equation by the smallest number I can to make a perfect square, which in this case is 2. So 2 is going to multiply 2x squared to get 4x squared. Negative 6x becomes negative 12x. And negative 5 becomes negative 10. Now I need to get my constant terms on the other side of the equation, so I'm going to add 10 to both sides. And I'm left with 4x squared minus 12x equals 10. And I left that space there because I need to add b squared over 4a. So I've got negative 12 squared divided by 4 times 4. Remember that when you go to put squares in the calculator and you're taking the square of a negative number, it is incredibly important that you put that negative number in parentheses. So you end up with a positive number. I know that 4 times 4 is 16, and I end up with 9. So that's the number that I am going to add to both sides of my equation to complete my square. So now I can take the square root of the front, which is 2x. I bring the sign of the middle term down, and the square root of the back. And I square it. And I add the two numbers on the other side. So now I've got my quadratic ready to solve using the square root method. So I'm going to take the square root of both sides. And I end up with 2x minus 3 equals. And 19 is not really ringing a bell for me as being one of those perfect squares. So I take the square root of it. Whew! I get a really long decimal. So I'm just going to leave it as the square root of 19. So I've got 2x minus 3 equals the square root of 19. And I also have 2x minus 3 equals the negative square root of 19. Now this might seem a little scary, but it actually ends up being easier because we treat that radical, this piece right here, like a variable. I can't actually combine any of the things that I move over with that square root. So I add 3 to both sides. I've got 2x equals the square root of 19 plus 3. And then I divide by 2. And I'm actually done. There's solution number 1. I add 3 to both sides. I divide by 2. And I'm done. There are 2 solutions, or 2 x-intercepts. All right, last example, all the marbles. This time we've got a real-world situation. The height in feet of a baseball thrown into the air from a starting height of 5 feet with an initial velocity of 64 feet per second can be modeled by the following equation, where t is the time in seconds. How long is the ball in the air? So let's make a quick picture. Here's my dude. Here's his baseball. He throws it, and when it lands on the ground, it's done being in the air. So this is the part that we're looking for. So I'm going to write my equation and I'm going to set it equal to 0 because I'm looking for when the height is 0. And now I want to move my constant term to the left side of the equation. So I'm going to subtract 5 from both sides. And I end up with negative 5 equals negative 16t squared plus 64t. And I look like I'm ready for completing the square, except remember that a has to be a perfect square. And there is no number that you can multiply by itself to get a negative number. So I'm going to divide everything by negative 1. So I actually end up with positive 5 equals positive 16t squared minus 64t. And I'm ready to go. I've got to find my b squared over 4a. So I've got negative 64 squared divided by 4 times 16. So I'm going to use the calculator to help me out with that one. So the first thing I'm going to do is square negative 64. And I've got 4,096. And then I'm going to multiply 16 by 4, and I end up with 64. I take care of my division. All right, I can handle working with 64. So that's what I'm going to add to both sides of my equation. So the left side gets the plus 64, and so does the right side. Now I've completed my square, and I end up with 69 equals the square root of the front, the sign in the middle, and the square root of the back squared. And I'm ready to go for solving with the square root method. Take the square root of both sides, and I end up with 4t minus 8 equals the positive square root of 69, and 4t minus 8 equals the negative square root of 69. So I've got a two-step equation to solve. I'm going to add 8 to both sides. And I have the square root of 69 plus 8. And then I divide by 4. Now, because we're dealing with a real-world application, this part we are going to put into the calculator. So I'm going to take the square root of 69, and I hit enter, so that I can then just hit plus 8. Oh, hold on. Let's try that again. Square root of 69 plus 8. And what that does, there's an A and S. It takes the previous answer and does the next operation. And then I divide by 4. And I end up with 4.0766, blah, 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 blah. We're going to round to the nearest hundredth, which is 2 decimal places. So I end up with 4.08 seconds. When I do that on the other side, I end up with negative root 69 plus 8 divided by 4 negative square root of 69 gives me negative 8.3. And when I add 8, I still have a negative number. And when I divide by 4, I still have a negative number. And this is negative 0.08 seconds. We aren't time travelers. We're not going back in time. That solution doesn't apply. So the final answer to this math problem, how long is the ball in the air? The ball is in the air for 4.08 seconds. Whenever we've got a real-world problem, we need to make sure that our solution is written within the context of the problem. That means a complete sentence. So there you go. A little more complicated with the square, with the completing the square, but it's not that bad. So take a chance and give the your turns a try. And when you've finished, make sure to have them checked before moving on. We've only got one method to go.